The simplest sort of way of controlling execution is to decide whether or not a particular piece of code should be executed or not, based upon some condition. This could include computing a particular value for a function in the special case where x equals 0, or testing if an input is good and only computing values if it is, or executing different pieces of code depending on a command string read from a file. In each of these cases, we execute the code if some condition holds. So the statement in Python and many other languages that lets us do this is called the if statement. The simplest form of the if statement looks like this. This will execute the print statement if the condition x greater than 0 holds true, otherwise it will skip to the next statement. If you've programmed in other languages like C or Java, this should be reasonably familiar to you, but there are some differences. One immediate one is that there are no parentheses. Where languages like C and Java use indentation as a matter of style and readability, Python uses indentation to group lines of code. In this example, the two lines of code, print hey and print x is positive, are called a block of Python code and form the body of the if statement. You'll notice that the last character in the line before the block starts is a colon. This is required and signals to Python that an indented block is about to start. We will see that all flow control statements in Python expect a colon at the end of the statement. The block ends when Python encounters a line of code which is indented at the original level. So, for example, that line is still part of the block, whereas this line, we can run this, and you can see that when x is greater than 0, all of the lines print, but if we change this, so for example, this is a negative number, and run it, then only the last line, which is not part of the block, prints. You may notice that we indented 1, 2, 3, 4 spaces. You can indent the lines of a block any number of spaces as long as all the lines have the same indent. But the Python community has largely settled on 4 spaces as being the preferred indent, and that is what you should use. You can use tabs instead, but you can end up with odd interactions between tabs and spaces. The Canopy Python code editor overrides the tab key to instead do indenting with spaces. If you're using some other code editor, you should change your preferences for Python files so that tab indents with spaces rather than tab characters. Sometimes there may be a number of different conditions, and you want to do a different thing in each possible case. The if statement can have additional blocks associated with it via the elif and else clauses. So you can see here we have one test for x greater than 0, one test for x equals 0, and then anything else falls into this third block. So when we ran it here with x equals 0, it printed out x equals 0. If we change this to make x equals 1 and run it, then it'll print out it's positive. We make x negative and run it, then it prints out it's negative, falling through this last block. You can have as many elif clauses as you want, but you can only have at most one else clause, and the else clause must always come last. In addition, Python will only execute the first block of code that matches. So here, if we set x equals 0.5, actually let's make this x equals 1.5, and we run this, then we see that it only executes x is greater than 1, even though it would match the condition x greater than or equal to 0. If you wanted both to print, you should have used 2 if statements, like this, or even nested if statements, like this. So if we run this, we'll see that in both cases, all the lines of code work for 1.5, whereas if we choose 0.5, then we only get the lines x is non-negative printing. The other thing we need to consider are the conditions that can be used in if and elif clauses of if statements. Unlike some languages, Python will accept any expression as a condition. Usually it will use a logical expression, as described in the Introduction to Python lecture, but any other expression will be evaluated and tested for truth. Most Python values will test as true, but a handful test as false. These include false, 0, none, the empty string, and empty containers such as lists, tuples, sets, and dictionaries. And occasional custom classes may have instances which also test as false. This means you can do things like this, where we take a list and we just test if mylist, and then either print out the first element, or if it's false, if it were empty, then it would print out there is no first element. So if we run this, you can see that because this list was not empty, it printed out the first element. If we were to make it empty and run it, you can see that it prints out there is no first element. You'll notice that we have a little warning here on the slides. Sometimes it pays to be explicit about what it is that you're testing for. The example we just did is safe and reasonably clear, but what we're really testing for is whether the length is greater than or equal to 1. So it could be more clearly, and perhaps more safely, written as this. This is particularly the case when you want to check whether a variable holds the special none value. You should always test for none by doing if x is none. Or alternatively, if x is not none. Rather than just testing x equals none or not x, as these may behave unexpectedly for some values of x. At this point, hopefully you understand how to make your own if statements, and you should attempt the if exercise. Having looked at the if statement, we will now continue on in the next lectures looking at how you do looping.